Hello, everybody. My name is Henry Sal. I'm president of Computing System Innovations, and we're about ready to start a live stream session. So thank you very much for coming into my session. We're going to talk about artificial intelligence and this new concept, something called large language models. In the past 9 months, there have been significant changes in the artificial intelligence machine learning world. They've been coined by others as being the Gutenberg printing press moment. They're that significant that they will be changing everybody's life. The concept of this new technology, large language models, actually is being applied to many different disciplines. The technology recently passed the SATs, which is the Scholastic Aptitude Test, scoring 700 on English and 710 on math. It actually just recently passed the Uniform Bar Exam, scoring in the 90th percentile. It actually passed a Google intern test for a software engineer, qualifying as a level 3 software engineer, being able to make $183,000 a year. Nothing like this has ever transpired before in the artificial intelligence world. Now I'm going to be telling you how it's going to be applied to court document processing. We'll move on. So we'll talk a little bit about my company, Computing System Innovations, talk about what it is that we've been doing for the past 4 or 5 years in the artificial intelligence space within court document processing, and we'll go into what the existing AI accuracies are possible with current technology, as well as what the transformational accuracies are going to be when large language models come into play. Then we'll talk about what large language models are. So CSI is a software company. We've been in business for quite some time. We got our start in the redaction space in the early 2000s, where we were having software engineers write languages called regular expressions to find information on documents to redact before they were made public. And we became pretty good at it. We ended up with a lot of customers. We processed over 7 billion documents in the time that we've started. We won the only 6-wide statewide RFP, so we're the garbage guys of collecting information off of documents, the garbage dumpster guys. In 2010, one of our customers, Clark County, Nevada, asked us if we would take the same technology and use it to find information off of documents, such as the case style, the parties, information that they needed. And they were happy because we essentially got rid of their backlog, but we weren't, because we had a very fragile solution. When documents changed, what happened was you had to have software engineers come in and modify code to be able to understand where to find the new language off of the new document formats. So for a couple of years, we struggled with this, and we were still offering the product IntelliDact to essentially automate document processing. And then in 2015, we decided we're going to enter the artificial intelligence market and put our software developers out of business. We shifted them from writing regular expressions to writing artificial intelligence software. And then in 2017, we released our first generally available product, and it was used by Palm Beach in 2018 to process the world's first e-filing without humans ever looking at documents. Okay, that is an attorney or a submitter sends a document into a portal. We intercept it. AI figures out what the docket code is, what fields are necessary to accept or reject it on the portal, and then to do data entry automatically into the case management system. And we have roughly 35 counties in the United States running this AI technology, and the Egyptian courts as well. But in 2017, when we first introduced this, the National Center came out with a white paper called Privacy Protection in Courts. They were talking about redaction. They asked me to come up and speak on the concept of why redaction was expensive, why it was inaccurate, and why no one really wanted to do it. And I said, well, you should use the technology, the money you're spending for redaction, to use it to do the data extraction off your documents and get your return on investment. We'll talk about that in a bit. But in that white paper, which was dedicated for only doing privacy protection, they actually took 3 pages and talked about how this new great technology would save courts 85% of manual labor from doing document review and data entry. So in 2019, we essentially improved the artificial intelligence so that it learned by itself. So that transfers to, if I've trained a system to understand a specific set of document types, then a new document type comes in, and the AI doesn't have knowledge in terms of how to find that data, it misses. That document goes to human to review it. The human makes corrections. This online learning concept takes the changes that were made by a human, feeds them back into the AI model, so the system continuously learns on the fly. Think of it as if you had a person and you told a person, here was your particular job, do A, B, C, D, and that's it. And all that person would do is A, B, C, D. But when E came along, they didn't know what to do. You'd have to retrain them, okay? So we've made it so the system learns on its own, okay? And that's pretty unique in the AI space. A federal government agency came in and they liked our technology so much they paid us to port it to Linux, and that was the US Army. So our technology currently processes 553 million pages a year for the US Army, extracting information off of documents. So it's not just limited to court documents, it's any document. We introduced handprint technology, so you don't have to just deal with typewritten forms. You could have pro se forms that people do handprint on. So we've added AI not just to the process of figuring out what the document type is or doing data extraction, but also we're doing the OCR piece, which is critical for getting data to the engines to be able to understand. Currently, we have our technology interface with 12 different CMS vendors in the United States. Okay, so it's not just a one-shot, one-client basis. It works against pretty much anybody's CMS. And as I mentioned earlier, we were hired by UAE to port the technology to understand Arabic, which was kind of a challenge because instead of reading left to right, it's right to left. So everything becomes backwards there, okay? But it worked and it was successful. Anyway, this is a problem that we solve typically in courts and clerks' offices. This is a traditional e-filing workflow where a filer submits something to a portal and that clerk review can occur either on the front side or the back side, it doesn't really matter. But you have a human looking at a document to say, is this the right filing? Does it contain all the data necessary? And yes, I'm going to accept it, and it's going to update my CMS. And you're looking at 100% of the documents that are coming in to catch about 10% of the errors. So you have about a 90% waste of staff doing this process. So in 2017, this is what we invented. So the first thing that happens is when the submitter submits a document, AI, traditional AI, performs OCR, which is essentially taking the image and making text out of it so we can use it for other things. Then AI does something called document classification, and this is very important because we're going to focus on this when we get into large language models. Essentially, irrelevant to what the filer said, we understand what that document is based upon its contents, okay? So there's an AI engine that comes along and says, oh, this is a notice of hearing, this is a motion to dismiss, this is a pre-order. Whatever it is that you're using on your document codes for your CMS, the system understands. Has two purposes for document classification. One is to catch errors. If somebody sends in a document that's a motion, they're saying it's a motion on the filing, but it's a notice of hearing, your users are going to reject it. So if you say it's a motion coming in on the portal, but the attorney made a mistake and filed another document which isn't a motion, we can automatically pin it back to the portal without anybody looking at it. That's pretty simple. The next one is pretty interesting, and that is for doing what we call generic to specific docket code matching. So let's assume that your portal makes it easy for the attorneys by having only a finite set number of docket codes, 20 docket codes, but behind the scenes you have 200. So your clerk was previously reviewing the document and deciding what the docket code should be for the CMS. Well, the AI model is trained so that it could actually do the differentiation for you. So if you're saying that you're filing a motion, maybe it's motion for XYZ, motion for ABC, that the filer doesn't really care about, but the CMS does care about. So the AI at this point in time classifies a document based upon its contents and then decides what to do with it. After we know what the document type is, we can then also figure out what the fields are that are on it that are necessary to do docketing into your CMS. So you need a certain set of data to be able to accept the image or the transaction on the portal. You need to know if the parties are correct, if the case number matches, things like that. But behind the scenes, once you accept that document, you typically have a docketing clerk that goes in behind the scenes and does additional things in this case management system. For instance, if you have a child support order, Maybe you need to know what date the child support starts on, what date it ends on, the dollar amount, and things like that. Items that are specific to that docket code. Well, until we know what the correct docket code is, we don't know what data to extract. But once we know what data to extract, we then automatically update the CMS. And what that looks like in production processing is this. Okay, so this is, whoops. Sorry about that. Let's try this again. So this is going to be a video of a filing off of a portal. I hope it will be in a couple of seconds. Okay, this is going to be a video of a human doing data entry onto a portal. There's nothing special here. This happens to be a Florida portal where the attorney or submitter is going to sign on and submit the transaction. And they're doing all the data entry required to add a subsequent filing to an existing case. There's no magic here. It's sped up a little bit so that we don't waste your time. But then what's going to happen is this transaction is going to end up at the clerk's office or the courthouse, and it's going to be processed by AI. It's going to be OCR'd, document classified, data extracted, and then a software robot is going to act as though it's a human, sign on to the case management system, and do all the data entry. So we call this the lights out path. What you're seeing at present is a screen that's just showing that the transactions arrived at the courthouse. Now we're going to switch over to actually a virtual machine that's running in a data center that no one ever sees, that's running 24/7 now. Okay, this is no longer an 8x5 operation. When you AI enable an input stream, you can run it round the clock. So this software bot signs on to the case management system as though it was a human, and then locates the case that it has to update for that e-filing that just happened. This is called lights out. Okay, this is the majority of transactions that we strive for in AI are lights out, which means no human ever has to see them for them to be processed. Now, these are software bots. The technology is called robotic process automation. That is not a product of our company. You can use anybody's robotic process automation. We do the AI piece to make structured data possible for the software bots to do their data entry, okay? But the whole concept here is that the more accurate the AI is, the less work the humans have to do, okay? So it's now, right now it's found the case, it changed the docket text a little bit, and it's now adding the image, and pretty soon it'll be done. But I want to show you the entire process before we got into why we want to improve the AI. So now we go back to the portal. And if we refresh it, we'll see the transaction that was pending is now accepted. So total round trip time, and I call this pizza delivery, because if you were ordering Domino's pizza, you wouldn't want to send it on your website and then find out 2 days later it shows up, right? Well, you're an attorney. You press submit. You don't want to find out 2 days later it shows up in your case management system, right? So total round trip time on this is about 2 minutes. Okay, a robot does the work of about 9 employees. Okay, and robots cost about $8,000. So times are changing. If you can't find staff because of COVID or Walmart's offering the same amount of money that you're paying for low entry data entry people, bots are the solution. Okay, but bots by themselves won't do anything. You need the AI piece to make structured data. Now, why do you want to do this? So this is production stats. I was just at a conference in Florida, actually in Florida where I am now. Florida Clerks Association in Palm Beach gave a presentation of what they were doing for AI. And these are their stats, and the important number to look for is the bottom right number. 32% of all their e-filings that come in are automated. That's based upon the core types and the document codes they want to process, okay? The benefit is you can see that their stats are the AI processes documents 4 times faster than a human can, less errors. They don't have to train staff to understand the system because the robots are doing all the work. But the biggest thing is the bottom thing in red. There's a push throughout the nation for agencies to provide access to court information quicker than clerks are currently accepting it, usually by news outlets when they want to find information. So if you're filing things and it's going to be 24 to 48 hours turnaround time and you can get it done in 2 minutes, you've just changed the equation on everybody, okay? So documents that are submitted end up in the CMS pretty quickly. So the attorney which is filing a motion the night before a hearing the next day is not going to have to hold up court while the judge says, "Where's my document?" And they run to the clerk's office and say, "Oh yeah, let's get this out of the queue and put it into the case." Okay, so that's volume. This is accuracy. 42% of the documents are never seen by humans with 100% data entry accuracy. When we typically automate a customer, within the first 6 months, 50% of their staff can be assigned to do other tasks. After about 1.5 years of the system running, 85% of the staff can be assigned to do other tasks. Okay, the return on investment is tremendous. Okay, so why are we here? I've just shown you that we have some software which does some pretty cool stuff. It eliminates humans being in the loop from having to review documents. So what do large language models have to do with this? Well, that number, 42% on the bottom, would be really cool if it was 100%, right? That means no one has to look at any document, okay? Typically with AI technology nowadays, a measure of accuracy is measured in the tenths of a percent. That's standard. If I'm 0.2 better, 0.3 better, that's major, okay? That's with traditional models. So let's talk about document classification. Okay. My technical term is bag of words. Wait, I need to give you a mic because I would be scolded.
Can you hear me now? Okay. So my question would be, it reduces human error, right? So, but the attorney filing or somebody that's filing, right? Say they're making numerous mistakes. How are they ever, like if you have a person, the person saying, hey, you filed this wrong, the wrong information, so you're letting the person know for the future, right? Who's filing on the other end to make those corrections. How does that happen in this situation?
So after the AI decomposes the document, it sends the information to a software robot. Then that robot is taught what to do, if it should update the case, or if it should send an email out to the attorney letting them know you have 14 errors on your filing, okay? Our typical implementations are, we do not email the filer, we actually send it back to the portal with all the error messages, okay? And the benefit is, we catch them all on the first pass. So if you're applying 5 business rules to a document, it has to be a PDF file. It has to have nothing in certain margins. Whatever your requirements are for your processing, instead of having a user find one error and send it back to the attorney, we catch them all, so we minimize the round trip times going back and forth at the same time. Okay? Thanks for the question. So let me get back to my technical bag of words. I was trying to find a clever way to describe what's actually going on. So what you see in front of you is an AI designer screen. On the left are all the unique DACA codes. And I have something called DCSMO as a top and a couple of other sub-DCSMOs. And then I have a motion with that little tree going down the right. Now for the document that I've selected, DCSMO, that's a wordle. Essentially, it's statistically what words on this document type are different than any of the other document types, okay? So the technical term is called TF-IDF, transverse frequency, term frequency, inverse document frequency. Forget about it, it's a bag of words. The more words that are different make this document different than this one. So if I have 5 docker codes, I have 5 bags of words floating around. And I get a new document that comes into my system. So what traditional statistically based AI does is it figures out what the words are on my new document coming in, and it figures out which bag it matches better. Does it match document type A more words, document type B, or document type C? And the more words it matches, the higher the confidence level is, and it tends to think it's that document. Sounds all good. Until the documents are really close together and the word difference is very, very small. So if I have 5 motions, and the difference between motions are typically only 1 or 2 words, the AI is going to get confused and not be able to figure out what that Docker code is. And when it gets confused, because the difference is so small, it throws it to a human, and less lights out, okay? So the technology today is relatively flawed when your documents look very similar in content. That occurs on all those motions and all those other things, okay? And when that happens, you have to have an AI engineer get involved and actually write special code to differentiate this document, which looks so close to this document because there's one word. That word's going to be statistical noise and being discarded. Bottom line is, bag of words doesn't work that good when you have documents that kind of have the same information in them. Okay, now this is a model. That's the bag of words. This is the same designer. On the right-hand side, you'll see a bar chart of numbers. And its DCSMO is green for 90+%. That means the document the AI has simulated processing thinks it's 90% sure it's a DCSMO. And all the other bag of words that it tried to fit in have lower confidence levels. So bottom line is, this document's a DCSMO. Okay. Now, large language models differ than traditional AI because they don't use statistics. So large language models were an invention out of Google in 2017, where I think it was 3 Google Brain staff members and 2 Google researchers and one researcher from University of Toronto came up with a new algorithm, and they actually thought they were quite cute, and they called it "Attention is all you need." There's a white paper out called "Attention is all you need," and that's transforming AI throughout the world today. By a show of hands, how many people use ChatGPT? Yeah, that's a large language model. So is Bard, okay? Statistical modeling, as it says, uses the presence of words and the types that are there. Large language models don't do that. They use a connection of every single word and every single sentence and every single paragraph and every single document that they've been trained on. Okay, the large language models that you're using for ChatGPT have been trained on every single document that's in existence on the internet. Okay? The more parameters or connections between words that the model understands, the smarter it is. So for instance, GPT 3.5 could not pass the bar exam. GPT-4, which was trained on more documents, passed the bar exam. The concept of parameterization is going up exponentially. You're exposed right now to models that may be in the millions or billions of parameters. Okay, right around the corner are the models that have trillions of parameters. Okay, there will be no difference between talking to a human and talking to a very, very large language model when Intel comes out with their 1 trillion parameter model. Okay, so what does this mean in terms of my lights out saving money? Traditional AI, the stuff I showed you with that word map and the bag of words stuff, if I hook up the best AI engine in the world, ours, of course I'm modest, no, to a training set, the most I'll get out of it is 70% accuracy without intervening a human to tune it. And remember when I was telling you that in the accuracy space, 1/10 to 0.2% means a whole lot. So if I had a human, an AI engineer that's a specialist, to go tune the model, I'd get up to about 80, 82% accuracy after about 2 man-months of doing refinements. Large language model, no tuning out of the box, 98% accuracy. That's unheard of. I get the hairs on my neck go up when I hear that, okay? We're the only company that's introducing large language models to courts. These stats that you're seeing are actually based upon data sets coming out of Palm Beach, Florida. They're our poster child guinea pig client. They believed us 5 years ago, so they still let us experiment with them. But we expect that 43% that you're seeing on the bottom will easily jump into the 70, 80% range of lights out, all because of large language models, okay? So what is a large language model? Like I said, it was invented in 2017, and it was invented to translate text between English and French. That was what the original guy set out to do. And the reason why they had to do this was you can't do a one-for-word word for translation between English and French. It's male or female types of words. Sometimes the words are switched. So you needed to take into context the entire sentence before you started doing your translation. So they came up with this idea, instead of looking at individual words, look at entire strings and look at all the relationships between the words. So all those little lines are considered parameters that the system has found in terms of that sentence. The technology that existed before could do very short sentences. It was called a recurrent neural network. It would only be able to take chunks of text, because when you started getting into massive amounts of text, considering all the text on the internet, it couldn't process it all. So it wasn't able to establish all the parameters that were needed. So it was not as good as what the transformers did. And the transformers are not Octopus Prime shows up and takes care of your data, right? It's named for the algorithm. So the same technology, it's a neural network, with the transformer model, allowed them to take the entire sentence, the entire paragraph, the entire page, the entire knowledge of all textual presented documents in the world, which is why when you talk to ChatGPT, I mean, I have friends that are writing their college papers using this, and it's not being caught for plagiarism because it's an exact work. It's an original work. It's not something they copied for someplace. Some of my really bad college friends actually submit it to get their grades on it, and they say they get caught for a plagiarism, but only on the quotes that are being used that the other systems know about. So it's that original. It can predict a lot of stuff. There is a statement made by Gartner that said that 50% of the jobs that will exist in 2030 don't exist today. There is a new job called a prompt engineer. They essentially do nothing more than ask ChatGPT questions. Their starting salaries are $350,000 a year. They know nothing about computers. They're subject matter experts in whatever they're doing, and they deal with large language models. Okay, so the concept here is large language models make the systems a lot more accurate, which are going to reduce the amount of humans that have to look at court documents when you apply AI to court document processing. Now, large language models are trained on enormous amounts of data. There are currently many lawsuits pending against all the large language model vendors because the people that own the proprietary data that somehow got into their large language models are saying you really shouldn't have access to this and therefore you're violating our intellectual property rights. So it'll be interesting to see how that shakes out in the world. A lot of people said they're used to using ChatGPT, so we're not going to discuss that. large language models are responsible for something called generative AI. Generative AI essentially produces works that were only possible previously by humans. You're used to it with ChatGPT, but it also produces artwork, it produces music. So things that were limited to what the humans were only able to process with their skill sets now can be digitized and done. How do they work? They take billions of sentences and they build a parameter base to figure out how all the words are connected. So when you type something into ChatGPT, all it's doing is predicting what the next word should be based upon the billions of connections that it's seen in what you've built so far. Okay? They predict sentence structures, grammar, and they can answer questions. And as I mentioned earlier, they can write white papers, they can write press releases, marketing material, even legal documents. They're built because they train off of existing documents. It's called supervised learning. They use a neural network. A neural network is essentially a representation of the brain inside silicon. So every one of your brain cells has a synapse and a connection to another cell, and these neural networks essentially mimic that. You've come into them by using personal desk assistants. They'll analyze data. Anything you can think of, you can probably go into your ChatGPT prompt. And there's also Bard, and there's other ones too, and it will answer questions for you. It might even describe itself. They work across not just court documents, they do medical, they'll do legal, they'll do financial. In fact, I have friends that are doing their financial portfolios based upon asking ChatGPT 4. And also there's versions of ChatGPT which aren't available to the general public. There's 5 and 6. The CEO of OpenAI, which is a company that created ChatGPT, OpenAI was actually started by Elon Musk and Sam Altman in 2016, I think. They're models that aren't available to the public because the people that created them think they're too dangerous to be provided. There is a ChatGPT model that is so powerful that Sam Altman, the CEO of the company that invented this, came out and said he would never release it because it would replace programmers. I have software developers on my team that feed their code into ChatGPT and ask it to find errors before they actually release it. Okay, it's that powerful in terms of the predictions. And it's all made possible with advances in hardware. And it learns and it's scalable. NVIDIA, which is, there's a concept of a CPU, central processing unit, and something called a GPU. GPUs essentially have a lot more capability for processing AI transactions than CPUs do. NVIDIA is a company which is leading in GPUs, just came out with a new GPU called the Alice Hopper GPU. And it's so far in demand because it can produce large language models really quickly and cheaply. Like maybe 1,000th of what the costs were to produce the current models you're using are available with this new introduction, and it's backlogged for the next 3 years because everybody's wanting to get one to make big, large language models. Okay, and what I want to leave you with, and this is going to be a short session because if I talk for an hour and a half, everybody will be asleep. The models are always improving, and everybody is trying to beat everybody else out. So the more parameters that a model has, the more smarter it's going to get, and the more accurate we're going to get being able to process court documents without humans looking at them. One last thing, generative AI. The last 10 slides you saw were not mine, they were done by a large language model. Okay? Any questions? That was me changing the text. Yes, ma'am. Oh, we need mic fronts for you guys. I think we do. Wait, you need.
Did you say that this system is currently being used by Palm Beach here?
Yeah, in about 35 other counties in the United States.
Is that list available anywhere?
My email address, and I apologize, I'm really bad at marketing, is hsal@csisoft.com. I'll give you a card and we'll give you the customer list.
Thank you.
We just won the state of Maryland for automating all the counties in there too.
You said the state of Maryland?
Yeah.
Okay.
You from Maryland?
I have a question. No, I'm from DC.
Ah, okay. DC courts have been talking to us.
Yes, okay, we will. So my question is related to confidentiality of information across systems. So when you bring a system into I guess if you brought it into Maryland, is it available to all of Maryland so that information is shared? Or if you bring it into DC, how is the information contained?
It's up to our customers in terms of if they want to share the AI knowledge. So when we deliver a system, it's typically on-premise or in the cloud, but the AI knowledge that's created off of your documents is owned by you. You can do whatever you want with it. You can share it, you can make it private.
Thank you.
I'd be interested in your take on the recent document that came out from nearly 400 tech experts that said that AI could definitely cause the end of human existence.
There's a lot of concern over AI being, what was the movie that had Skynet? Terminator, right? Yeah, I don't think we're close to Skynet, but I think that the people that, I'm sorry?
Maybe
Minority Report. Yeah, I've been doing software for 40 years. This is the most interesting time that I've ever encountered with the technology. I think.
That's a Chinese curse, by the way.
Yeah. I would think that what we don't know what it's being used for at present, we probably don't want to know. So think of all the military planning that might be going on that's using AI at present as opposed to like human decisions, right? Yeah.
I have a question. Good morning.
Good morning.
Is the human tuning based on error reports that the employee would receive to review, or how is that process done?
I'm sorry, so the question was,
So when the human tunes the information that's processed to review it, is that done on a report that is received?
no, so what happens is, I think the question was, if their human has to review something and correct an error, how it's reported on. So when you configure a system, you set the thresholds for what you think confidence level should be. You can say that you want the AI to be 95% confident, and if it's less than 95, it goes to human review. Instead of your humans signing on to your case management system or your portal, we give them an application which allows them to see the image and to see the document. To see the document and the data extracted. And then they make a change, okay? And then that gets corrected and sent on to the robots. There is a report that's available. We actually make it a dashboard, so you have real-time access, and you can specify the period of time that you want to see what your humans have changed, because you actually score the humans on did they correct it as well. Okay. Anything else? Yes, sir.
Curious, on the port where you showed like the different case types and the percentage that are done by AI, is that based on the court's preference for only allowing that percentage to be processed by AI? So it's basically a human choice of how much we want to allow the computer versus...
Yeah, typically customers don't turn on everything at the same time, because the hardest part was convincing clients that this actually worked. Because when we started in 2017, we were giving people keys to flying cars. And no one believed the car flew, right? So they weren't going to turn on all the court types and all the doc codes at the same time. So they picked their court types, they picked their DACA codes, and then they still don't believe us because they want to review everything that the software does before the robots do it. And then after we convince them that the software is more accurate than humans, they start turning everything off. They only want to look at the things that are bad, not the things that are good. But you do have the ability to configure it based upon court type, case type, and DACA code too. I think that's about, yes, ma'am. You have to use the mic, I think.
I think you mentioned this already, but I'm not sure. How much does the lights out technology cost?
The costs are based upon the amount of images you process per year. So you would have to let us know what those were and we can get you price quotes. A typical low-end installation is going to be in the very, very low six figures.
Okay, thank you.
Minimum volume to make this attractive is typically 1 million pages per year or greater. Anything less, humans can do. When you get in, we have customers that are doing 80 million pages per year. The typical customer is about 20 to 35 million pages a year. Because you're trying to save staff, right? Okay, that's it for me. So thank you all very much for attending, and enjoy the rest of your conference.